It's rolling.
Alright, so
in the shot.
That's all right, I'll scoot you over.
There you go.
Okay, so domain and range, I know you guys have talked about before, probably in Algebra 1 and in Algebra 2. We'll kind of go through it again because the graphing is like stepped up a notch and you don't really have a calculator. So we go through it again, and I don't want to bore you with it, but also I always get to this point and I think like, domain and range we'll fly through it, but it always seems to still present a bit of a problem. So we're going to look at it two ways. We're going to look at it graphically and analytically. Just to kind of give you some scope into where we're going. After domain and range, we're going to do limits again a little bit, and then we'll do continuity, and then we'll have a big test. Yeah. The test will be like on everything we've graphed, and domain and range. So basically everything we've done since the beginning.
Except the algebra.
Yeah. Except that algebra in the beginning. Yeah. That'd be good. What's that? Okay, so anyway, we're going to look at domain and range both graphically and analytically, and people don't always know what that means. Graphically means we're going to look at a graph and be like, here's what the domain is and the range. Analytically means we'll look at an equation and kind of figure out from there, maybe even without graphing it, or at least with minimal graphing, what the domain and range are. So I think everybody knows that when we talk about domain, we're talking about what the x's can be, and we talk about range, we're talking about what the y's can be. Right? That's not news, right? Okay. So when we talk about the domain, you can see how it gets kind of complicated, especially with these crazy piecewise functions, because you've got a whole lot of stuff going on. So first of all, we're going to use interval notation. Is that what Mrs. Griffin used last year?
Yup.
Yeah. The thingies and the u's. Okay, good.
I don't know.
The thingies and the U's.
What's that?
I was in level 2 last year.
Okay. So the domain, well, you'll see as we do it. So we're going to use this thing called interval notation. Basically, I'm kind of in this spiffy notation, writing down what the x's are allowed to be, and I'm skipping over the whatever numbers x can't be. So, when I'm looking at this graph and I'm looking at the x's, I literally try to read it left to right, and I say, alright, well from the left, like if I go this way, is there any x that's not going to get hit by this eventually? No. The idea here is this like parabola-ish thing is going to go down forever, and every x is going to get hit if I could go on infinitely. So my x's start at negative infinity. I put that in an open parenthesis, and I'll kind of say y in just a second, and then I go comma, and I want to continue over until I get to a place where I'm stopped by an x. So if I keep going over and I say, oh, -1, here's a problem. I have a hole here, but it's filled in here. So can x be -1 in this graph? Yeah, because since it's filled in here, that's fine. My x, in fact, let me actually open this one, just so we see the converse of that. So when I get to -1, I don't have to exclude -1 from the domain, because even though it's open here, it's closed here, so it's okay. So I keep going along, x's are fine, oh crap, oh, whoops. Something.
Oh, whoops.
Let's say this is x equals 1. I have a problem. I have a hole here, and it's still not open here. It's still not closed up here. So nowhere do I have a filled-in point at 1. So my domain skips over the point x equals 1. So if you're not familiar with interval notation, I say that my domain is from negative infinity to 1, and I use an open parenthesis. Open shows that the domain doesn't hit that number. It gets all the way up to it, but doesn't exactly hit it. So I go to 0.99, 0.9999, all the way infinitely close to 1, and I never actually quite get to 1. But then my graph continues, so I put this little UB-dooby, and I continue the graph just after 1. So interval notation, I put the 1 again, and these open parentheses just indicate that 1 got skipped over. But everything before 1 was fine, and now everything after 1 and all the way to infinity is fine and gets touched by an x value. So there's the domain. Does that make sense? Okay. Range, same idea, but I go bottom to top. So if I'm going down on the y, is there anything that can't get touched on the y-axis if I go down to negative infinity? Nope, this thing's going down forever, so all of my y values below here are going to get touched just fine. And as I continue up the graph, and I look at my y's, otherwise everything's still hit, everything's hit until here. I don't think I marked this. Let's just say it is -1. I'm not exactly sure where it was in the homework, but whatever. So -1, I have a hole, but do I need to exclude that from the range?
Nope.
Nope, because here I've got this line, so I'm fine, I'm fine, I'm fine. Even here I have a hole, but I've got this part. So I'm fine, I'm fine, I'm fine, all the way until the y value of 18. And should it be open or closed?
Open.
Open, because it's not going to equal 18. Is this like a total review? Some people yes, some people no. Okay. Doesn't really get that much harder. If you can do that, you can do any of them. So let's just kind of go through these two, because then when we do it analytically, I think it gets infinitely more complicated. So domain for this, pretty easy. What's the only number the domain can't be?
-3.
-3. So my domain is -infinity to -3, and then -3 to infinity. So -3 gets left out, but everything else is fine. The range, though, is like wacky. There's only 2 y values that are getting touched. My graph is like, this is 1 and, or -1 and 1. So the only 2 y values getting touched are -1 and 1. There's different ways to write this. I write it like this. I put a closed parenthesis around 1, and then, around -1, and a closed parenthesis around 1. And that indicates that the range is only the points -1 and 1. So people who aren't familiar with interval notation, open means that value is not included. Closed, or the bracket, means that value is included. That is the difference.
Like greater than or equal to type of thing.
What's that? Yeah, exactly. Yeah.
What's the downward U? Like, what's
I don't know. I have no idea.
Is that like intersection?
No, I think it's like, I think it's an and. Yeah, like this is like
This is the union of.
the union of these two sets, but does and mean like it's the
intersection.
So for example, if I have like -3 to 2 and 0 to 4, what am I really, like that, what am I really talking about?
Would it be -3 to?
No, I don't think that works.
You would have to do like
No,
one
that
where
wouldn't
there's,
be
like,
any
the
of my
same
things. That's the one that like
Well,
they both
if
had
she
in
doesn't
common.
know it, then I don't know it, so
Yeah.
I'm
I
okay.
think that's the one that they both have in common.
I remember taking a class in college where we used it, but I don't remember what we used it for.
So we don't need to know that.
You don't need to know it. Yeah, it never comes up for us. Did it come up for you guys last year?
Yes.
Oh, weird. I should probably figure that out.
Nah.
Alright, try this. See what you think it is, and I'll go over it.
I didn't even draw this
Slacker. Just kidding. Not that hard, we just gotta think about it. Makes my head hurt. Then what? There's your email.
How would you write that?
Yeah, I'm curious what people think. So is domain okay? -infinity to 0, 0 doesn't work. Then 0 to 4 has to get left out. And 4 to infinity.
Uh-oh.
Yeah. 0 is an asymptote. So 0 is never getting hit by an x value. X can never be 0. Domain is like what the x's are allowed to be, what is getting touched along the x-axis. So like every x value is getting hit by this graph, hit by this graph, hit by until here. And x equals 0, nothing is ever going to cross over that spot. No x can ever be 0 in this. So I skip over 0 because it's an asymptote. 4, same thing. When I get to 4, I have 2 open holes. I have nowhere do I have an x value at 4. So I have to skip over it. Okay.
Yeah.
When I do the range here, it's just a little bit weird. So I go -infinity and up, Do I have to stop at
Okay, I
negative
didn't include
3/16?
any of that.
Nah, because the
No.
other side.
I've got an asymptote at 0, so this is going to keep going closer and closer to that asymptote.
Well,
It'll
I
never
forgot about
exactly
that.
hit it, but it'll almost hit it, so I only have to skip over 0. Then I jump up because I don't have anything getting closer to this asymptote. So I don't go from 0 again. I skip up now to the square root of 6, and I go up to infinity from there. Is that okay?
Wait.
I feel like that one's the upside down.
For what?
Because you like have to skip so many numbers. Like
I
I just remember the U with like the same numbers.
The second one, I don't.
The upside down one.
Why is that one closed?
Because the y value is -1 and is
Ow,
1, and those are the only two y values. So I
Okay.
close it to indicate that the y values are -1,
Just
they
where
are
they
that, and they are 1.
Right.
And that's it.
You should get your own
Okay. Yes, sir.
I did. No, I had a whole I lost it.
Because this, like, since I'm thinking about what y values get touched, this graph is going to hit negative 3/16 and everything else that gets closer and closer to 0. So, like, because this hits all those y's, even though this doesn't, the graph in general touches all of these y's.
Yep,
Yep, what?
Really?
that's right.
Like all your favorite.
Thanks,
like,
Max.
your favorite.
Anytime.
Okay, analytically, here's where it gets a little bit harder.
I don't want it.
But they're not your favorite. You can have your favorite. Yes, you can. Favorite type of pencil. Well, yeah, you can have your type of pencil, but the pens you get your favorite pens. So you can't. Yeah, I had this one pen I stole from the deck of
Okay, for domain, if you're talking about looking at an equation and deciding what the domain is, there are 3 big no-nos. 3 huge, crazy things that mathematicians' heads pop off if they happen. So they cannot happen or our brains will explode. One of them is, what can't you ever have, ever?
0 in the denominator.
0 in the denominator. I can never have 0 in the denominator. Or math teachers freak out.
I just wrote denominator.
What else can't you have? You can actually, but it's not real. Negative in a square root. Alright, fine, we'll write negative. Okay, can't have a negative in a square root. The third thing, I don't think you would come to your head. Anything has to do with logs. You can only take, how should I say? You can't say denominator, you can't have negative, you can't have, I'll just write logs have to be greater than 0, not even equal to. You can't take the log of 0 or anything less. That's not going to be really important to you until we get to logs, but I didn't want to not put it in. So, if I have an equation like this, let's go with the doozy right away. I have no idea what that looks like, but algebraically I can figure out what the domain of it is. Because two big things, are jumping out at me. Number 1, I have a square root, so I know that I can't have a negative number under there. And number 2, I have a denominator, I know that that can't be 0. So here's how I think it through. I think alright, I know that x has to be bigger than or equal to 0. It's important you don't miss the or equal to, because you're allowed to have 0 under there, right? I can take the square root of 0 and that's fine. So I know that x has to be bigger than or equal to 0, and I also know that x minus 5 can't equal 0. So what can't x equal?
5.
5. So these two things are true. So I kind of break it down algebraically and make a little equations out of it, and then I try to put them together in my head to think how to list this interval notation. So I know that x has to be bigger than or equal to 0, and it can't be 5. So my domain is going to start where? 0 with an open or a closed parenthesis? Closed, okay? Because x can be 0, because I can have the square root of 0. And I can keep going all the way up until I get to 5. I've got to leave an open parenthesis at 5. And then I can start up again at 5 and go all the way to infinity. And beyond. Parenthesis means it's not going to equal whatever number's there. Bracket means it will. Okay, so that's not hard. Okay, what about range? I should have said that. Range for that problem I'm not going to ask you because it's really just too complicated.
We'd have to graph it.
You'd have to graph it. Now you wouldn't really have to, but we don't need to go there right now. So I'm going to skip range for this one. And I won't ask you a range problem that's like that. But this one we're going to talk about range. Oh, why did I write range? Sorry, I meant to write skip. This is y equals x over x squared minus 2x. The domain is the easier part. So when I think about domain, there's only one illegal thing happening, and that is the denominator could be 0. So x squared minus 2x can't be 0. Just a little note, what do you think the answer, what do you think x can't be then? 2 or 0. You gotta be careful you don't miss the 0. Don't think that you can add 2x to both sides. Don't do this, and maybe don't even write it down. If you go x squared then can't be 2x, and you divide both sides by x, and you get x can't be 2, you miss one of the solutions. The other solution is 0. Don't do that. Don't want to ever divide through by an x. What you want to do instead is factor this, and then you'll see your two solutions there. You know what I mean? If you don't factor it, if you try dividing both sides and getting both sides divided by x, you miss a solution. So for the domain, I know that x can't be 0 and it can't be 2. So that's easy. I'm going to go from negative infinity to 0, 0 to 2, 2 to infinity. The little u thing, whatever, you're supposed to put it, but it's really not that big of a deal. But the range. What you want to think about with range is think about horizontal asymptotes. When I give you these analytical problems, the places where you're not going to have an easy to find range, or the places where the range is going to not be all real numbers, is wherever you have a horizontal asymptote. So for this problem, when I think about range, where are the horizontal asymptotes? Yeah, I look at the degrees, right? Degree on top, degree on bottom. I got x to the first over x squared. When the bottom degree is bigger, where's the asymptote? Y equals 0. So I have an asymptote at y equals 0. That means whatever this thing looks like, at y equals 0, it's not going to be there. I'm going to have an asymptote. Now, yes, it's possible for graphs to cross their own asymptotes. I'm going to give you some pretty straightforward problems that don't cross their own asymptotes. So the ones I give you are going to have, if you think it has a horizontal asymptote, it does. So this range is going to go from negative infinity to 0 and 0 to infinity. It'll skip over the horizontal asymptote. Is that okay? Okay. Alright, let's try another one. See how it brings everything together? So fun.
Oh my god, they totally just used all of that.
No, they didn't.
Oh, Jesus. Goodness.
I had it like that.
Yeah, it was all cut off.
Alright. Well, now they can see it.
Who's getting this one?
Allison, she has strep throat.
She's always sick.
Now we
She always has strep throat.
I'm sorry, Allison.
We're
You should
sorry,
get your
Allison.
immune system checked out.
get some vitamin C.
Oranges. Oranges.
That's the one who's always sick.
Okay. If you have this, and you want to think about its domain, the denominator can't be 0, right? Well, the x squared plus 4 should kind of jump out at you a little bit, because is that factorable? No, it's not a minus. So is there any place where that denominator is going to equal 0? No, there's no real places. So my domain is fine. It's negative infinity to infinity. Okay, because that denominator is never going to equal 0. X squared plus 4 is never going to be 0. Doesn't work. The range, I just have to look at the asymptote. So where does this have a horizontal asymptote? At 1. Okay, I've got the same degree. I take the, I reduce it, whatever, so reduce this to 1. So I'm going to go negative infinity to 1
Do you do like the 2 circles?
and 1 to infinity.
I feel like that's what you do.
Is this like super easy?
See, that one wasn't as good.
See, 'cause
And you know.
Because it was under stress.
We'll try one more because it's hard, and we'll go, and then we'll stop.
But see, she messed up on that one too, so it's okay.
No, I'm just messing up all over the place. Look at my last two.
Oof, they look like mine.
Okay, I have no idea what this one's gonna look like, but I'm looking at it analytically anyway. So any ideas? Yeah,
I was just gonna make the denominators the same.
yeah, I would too. Okay, I would make the denominators the same and put this thing together. So a common denominator would be x times x plus 2. So on the top I'd have x plus 2 plus 3x. Do you know how I do that?
Well, you gotta cross multiply type of thing.
Well,
Isn't it just 4?
Multiply by
No,
x.
but you
plus
distribute.
Yeah.
like if I'm going to make them both have x plus times x plus 2 on it,
Yeah,
this one needs an x plus 2 on the top,
Yeah.
that one needs the x on the top.
yeah.
I did that just in one, step.
So it just becomes 4x plus 2.
4x plus 2.
Oh, that's fancy.
Alright, write down what you think the domain and range are for this one.
Wait,
I don't know.
negative 2 to 0.
Am I right? Oh, negative 2.
Yay.
Is there a horizontal asymptote?
Is there what?
There's no horizontal asymptote.
It says 0.
Here.
Multiply this out to see that the degree on the bottom is really x squared.
What about for the range though? I thought you only looked at the top.
So wait, before you, I don't want you to back up quite yet, hold on. The domain, I look at the bottom, is this okay? When x is 0 or negative 2, I have a problem. For the range, I have to look at where the asymptote might be, the horizontal one. So my power's 1, my power's 2, when I reduce them, I get 4 over x, and as x goes to infinity or whatever, this is 0. So I have that horizontal asymptote at 0. So for the range, 0 is going to get skipped over, yeah.
Do you even have to put it all together because you get the same answer?
Yeah, I did it before and I got the same
Yeah.
answer.
I don't know if there's one instance where that might not work, but right now that seems like it's fine. Real quickly, what if you had this one? I forgot about this. The square root of x. What's the range on that?
0 to
Has to be
infinity.
greater than
0 to infinity, and it's included, okay?
yeah.
Because you want to think about what that looks like, and it looks like this. Sometimes if they're simple, just think about what it looks like and go from there. Okay, the homework's slightly more than 5, but I still made it small. I'm sorry. I just didn't want you to not get the practice.
Did you get that
It
example
is
in?
a worksheet, but
It's
it's also
like-
from the book. It is do
Right
this
there.
one,
Allison.